nation. I'm a soldier, won't surrender. Faith is like a fire that never burns to embers. The voice of the unheard. Love is the answer.
I gotta speak it, believe it, that's how I feel inside.
I can't sit here quiet.
Welcome back to programming with C++. This is week 3 and today we're exploring some very important concepts. Pointers, arrays, references, structures, signals, and numerations. Let's dive in. Objectives. Objective 1. A second. Objective 1. In this session you will be introduced to pointers, learn about arrays, understand how pointers work with arrays, explore references, learn about structures, union, and enumerations. So, a pointer. What is a pointer? A pointer is a variable that stores the address of another variable. Pointers can be used with any data type. Creating a pointer. A pointer is declared like any other variable, but with an asterisk. So here's an example. It with an asterisk, and another example, an int with asterisk and print. Sorry, the PTR is pointer. Assigning an address to a pointer. We use the address of operator. Sorry, we use the address of operator. That's the end symbol to get the address of a variable. So here's one that's value. That's for getting the address. That's in C++. Any variable in C++. Differentiating a pointer. Differentiating means accessing the value at the address the pointer is holding. So here's an example of it. Modifying the pointer address. Now let's finish with this one. So here's what you get when you access the value. So the address of the pointer variable ptr is the address, and the value of the variable is the value 10. So this is the address of variable var stored at ptr here. So modifying the pointer address. The pointer can be modified to point to another variable at the same time. So here's a code for something like that. Now, data sizes of pointers or pointer sizes. All pointers have equal size depending on your system. 8 bits on a 64-bit system, 8 bytes on a 64-bit system, 4 bytes on a 32-bit system. So there are special types of pointers. So here's the code for getting the data sizes. So there are special types of pointers. Now these are wild pointers, contains random memory address and may not be valid. Null pointers points to no valid memory location. Void pointers point to values of no particular type. So these are two different things. Keep that in mind. Dangling pointers points to memories that have been erased. Now, references. A reference acts as an atlas for an existing variable. It provides another name to access the same data. Now, references versus pointers. A pointer allows us to pass potential large amount of data around it at low cost. Instead of copying the data, we simply pass its address as a pointer value. Now, creating references. We use the ampersand, that's the end symbol, to represent it. So application. Here is an example of the application of it. That's passing arguments by reference. Then returning reference from functions. Now, what are the properties of references? It can be accessed just like normal variables, always allows the object it initializes with, plus no null references exist in C++. Arrays. An array stores multiple elements of the same type in contiguous memory. Sorry, I said contiguous, sorry. Contiguous memory. Now, define an array. This definition of an array, that's the syntax, the example, and the data size. Index of an array. Arrays indexes start from 0. So for a 10 element array, so for a 10 element array, this is it here. Now, initializing arrays. Initializing arrays refers to define the elements it contains. A list containing the values for the individual arrays elements is used to initialize the array. This is an example of it. Accessing array elements. This is another part of the initialization. Accessing array elements. Accessing array elements refers to viewing individual array items. Structure, array name, parentheses, index. Wait, no, I'm not sure this parentheses, whatever. Example num3. Now, multi-dimensional arrays. Arrays with columns and rows. Two-dimensional arrays are data type, array name, size 1, size 2. Now, declaring 2D arrays. Two-dimensional arrays have rows and columns, can be visualized as a table or matrix. Declaring three-dimensional. Three-dimensional have rows, columns, and depths. Extract. Extract group. Extract is a sequence of elements of types used to create user-defined data types. So how do you create structs? Here's an example of creating a struct. Then creating a struct variable. After creating a struct variable must be created. So here it is, struct underscore name variable underscore name, struct underscore name variable underscore name. So here's an example of creating a struct variable. Then creating a struct variable with definition. So this one, it can be declared with its definition. That's the struct name, type 1 memory 1, type 2 memory 2, variable 1, variable 2. So here's also another example with a character, with a gender, and the age of a student named Julia. So accessing a struct member can be accessed using a dot operator. So here it is. So when you want the output as you want to access it, you put a dot there because it's a struct, because you're trying to access the struct. Assigning a struct member. A struct member can be assigned using the assignment operator, that's the equal to sign. So this like you're assigning a variable or a number to it. Union. Now union is basically, it's very similar to struct, but with one big difference. A union can hold the value of just one of its members at any time, or one of its members at any one time. All members of the union share the same memory location. Now, the definition of it. Sorry, what's this PC doing? Creating or defining a union. Here is an example creating hashtag include IOStream using namespace std int main bracket close bracket close parenthesis union student int age int gender return 0. Now creating a union variable. After creating a union variable, a union variable must be after creating a union variable must be created. That's the union underscore name variable underscore name or union underscore name variable underscore name. Alright, so here's an example of a union and creating a union variable with definition. Union variable can be declared with its definition. That's type 1 member 1, type 2 member 2, then variable underscore name. So we have this. Then accessing union. A union member can be accessed using the dot operator. It is just like the struct. You use the dot operator. But here's the catch. If you then assign a value to the name Julia in terms of gender, the previous age value is lost because they share the same memory. So importance or properties of unions. All members share the same memory space. Only one member can hold a valid value at any given time. If you try to read a member that wasn't the last one written to, you might get undefined behavior. So we've gone through all of this, so we ask ourselves one question: why use union? So why do we use union? Because they are memory efficient, because they allocate enough memory for the largest member. They are useful when you need a variable that can represent different types of data at different times but not simultaneously. Now in a struct, each member has its own memory, whilst in a union all members overlap the same memory space. So here we have struct versus union. So as I said, allocate memory for each member variable sequentially. The size of a struct is the sum of the size of its members, including padding for alignment. Members can be accessed independently at any time. Used this for structs, by the way, used to group related data of different types. And for the union, allocate memory only for the largest memory variable. All members share the same memory location. The size of the union is the size of its largest number. Only one member can be active, which means holding a valid value at a time, used to save memory when only one of several members is needed at a time. Now, enumeration. So when we talk about enumeration, what's enumeration? Now, an enum is it's a user-defined type with a set of named constants. It holds a set of integer values specified by the user. The possible values are named and called enumerators. Two types of enumerators. There are two types, which is the enum classes and plain enums. They make your code readable and organized. So enum class enum class uses classes for defining enumerations. That's the enum class color red, green, blue. defines an enumeration called color. The enumerators are red, green, and blue. So what enum classes, they help avoid name conflict and provide stronger type checking, as is shown here. Then the plain enums, they are traditional style, but simpler, but they are less safe. They are simpler but less safe because they can be unnamed. That says the unnamed plain enums are used when a set of integer constants are needed rather than a type to use for variable. So an example is this, where here we didn't even give the enum a name. These are often used when you just need a set of integer constants. So the key features of enums: default values. The first enumerator starts at 0 unless you assign a different value. Auto increment. Each following enumerator increases by 1 automatically. Readability. Instead of using arbitrary numbers, it uses meaningful names. Why do we use enums? To make code easier to read and maintain, to avoid using magic numbers in your code, and to group related constant values together with one name. In short, use plain enums for simple set of constants, whilst you use enum classes for safer, more organized enumeration in C++. Alright, thank you all for joining this class. If you felt okay with today's session, like and subscribe. I'll see you in the next one. Bye.